Okay, so in this lesson I want to talk a little bit more about energy problems involving circular motion and the trigonometric functions. It's all based around the principle of conservation of energy, which says in a conservative system the total change in mechanical energy is equal to zero, which we know means that the total energy at any position is equal to the total energy at any other position within that conservative system. So here we have the idea: a ball bearing of mass 1 kilo hangs at the end of a light inextensible string of length 1 meter. So we've got a ball bearing here, mass 1 kilo, hanging at the end of a light inextensible string of length 1 meter. The other end of the string is fixed to the ceiling, so that's fixed up there. The mass is given a horizontal velocity, so it's pushed horizontally in that direction. It won't keep moving horizontally. I'm hoping you can visualize here that as soon as it starts to swing, it's going to start moving in a kind of a circular motion. Find the angle the string makes with the vertical when the ball bearing comes to rest. So it's going to go up to some kind of angle. I don't know what that is. Let's just call it A. There's some angle, and then it's going to stop there, and then it's going to swing back down, go beyond there, and it'll kind of keep swinging backwards and forwards until it eventually stops down here. That's the idea, and important to be able to visualize what's going on, to take the English and turn it into some kind of picture, some moving picture really in your head. And now I'm going to think about all the various different things. So we're talking about a conservative system here where the total energy at position 1 is equal to the total energy at position 2, and mechanical energy is made up of potential energy and kinetic energy, so the sum of those energies at position 1 will be equal to the sum of those energies at position 2. Okay. String is of length 1 meter. What I'm going to do is I'm going to call the bottom position just position 0, which would mean right up here is position 1 at the top. And I'm also going to, think about a few other things. I do know that at position 1 here, down at the bottom, the height here of this is 0, because I'm just setting that as my base height. So I'm going to say mgh will be 0 because h is 0, so there's no potential energy down here. It's going to be all kinetic energy. Also, the ball bearing swings up until it stops at this position. At this position, if it has stopped, then there is no kinetic energy, so it's all potential. So in other words, during the course of the motion, while the ball bearing travels from that low position up to this position where it stops, all of its energy is transferred from kinetic into potential. And we know that kinetic energy is calculated as a half times m times v squared. I'm going to write u squared for initial velocity, and that's equal to mgh. So what's the height? What is the height? So I'm going to start plugging some stuff in here. One thing I want to think about is the height, and I can kind of, if I know my trigonometric ratios, I can work stuff out in terms of the angle. So if I take this kind of height here, what is that? Well, this is going to be a little right triangle with a hypotenuse of 1, because the string has a length of 1, so the hypotenuse is 1. And using my basic definitions for sine and cosine, well, the adjacent side, remember, cosine is equal to adjacent over hypotenuse. So the adjacent is always going to be the hypotenuse times cosine. That'll be 1 times cosine of the angle. So that's going to be cosine of the angle. And similarly, this opposite side would be sine of whatever the angle is here. Which means my height, this height in here, well, if that's cosine A, and my string is length 1, this length in here, which is giving me my height, is going to be 1 subtract whatever cosine of A is. is 1 subtract whatever cosine of A is. So I can start plugging things into my formula now. So I'm going to have a look here. It says a half times the mass of the object. The mass of the object is given as 1. And in fact, you know, it doesn't really matter that it's 1 because the masses cancel there. So a half times the initial velocity squared. Well, the initial velocity is given as 3, so that's going to be 3 squared. And that's going to equal to g times the height. And the height here is 1 minus cosine of the angle A. And now I can solve for A. From here on in, it's a fairly straightforward trigonometric equation. So, squaring and multiplying, that's going to be 9 over 2 is equal to g, subtract g cosine A. And solving there, adding g cosine A on both sides, and subtracting 9 over 2 on both sides. And now just dividing on both sides by g, we'll get cosine of A is equal to g, subtract 9 over 2, all over g. Okay, so we have a value for cosine of A. Let me just take that over here. I'm going to plug in 9.8 for g. I'm going to put it into my calculator. So 9.8 subtract 9 over 2 all over 9.8 equals, so I'm getting cosine of A there is equal to 53 over 98. That's what I'm getting for cosine of A. And again, A is an acute angle, which means that A just must be the cosine inverse of 53 over 98. And we can approximate that using our calculator. Shift cosine inverse of that answer I just got. And I'm getting about 57.26 degrees. So the angle the string makes with the vertical when the ball bearing comes to rest is about 57.26 degrees. Okay, so that's the principle of conservation of energy, and those last couple of examples just bringing in some circular motion and a little bit of trigonometry. And that kind of concludes that section, so make sure you practice lots of questions from that section 6b.